Hey people, Mr. Smith here. Before we start this video, just wanted to say, as always, my best wishes, thoughts, prayers to you and your family right now. I know that the virus situation is impacting us all in different ways and varying degrees, but regardless of how it has impacted you and changed your day-to-day life, know that I am here for you, and I'm happy, more than willing to support you whatever way you need. So if you need math help, you got it. If you need help with something not math related, you got it. If you need somebody to talk to, you got it. If you need somebody to make you laugh, you got it. Whatever you need, you can reach out to me. Okay, I'm serious about that. I care about you guys more than I care about math, and I'm here to support you however you need. All right, so let's get into this video. This is the only video for this week. We are talking about exponential growth and decay functions. All right, how we can use exponential growth and decay to help us model some real life situations. So let's think about this for a second. Consider the situation. You and the members of your group, we're not really in our group right now, so just think you and your friends, I guess. You and your friends decide that you want to try to buy Mojang. I think that's how you say that. I don't really know, but that is the company that develops Minecraft. You want to buy Mojang so that you can just play Minecraft for the rest of your lives. I've never played Minecraft before. I've watched a number of students play it, and I don't understand it. But maybe you're super into it. So pretend in this scenario you're trying to buy Mojang so that you can just play Minecraft for the rest of your lives. And when you pull together your resources, you have $10,000, which is a good amount of money. If you deposit your money into an account which pays interest, how many years will it take for you to have enough money to buy Mojang? If you have $10,000 to start. Okay. So I just want to think about this for a second. What information do we need in order to answer this question? We don't know everything that we need to know in order to give an educated answer to this question. Okay, so let's just think about it for a minute. Maybe you already have some thoughts. If I want to buy Mojang, I probably need to know how much does Mojang cost. That's important, right? I need to know how much money I'm trying to get, how much it costs, so I know how much I need to sell for in order to buy it. Okay, the other thing that I might need to know has to do with this word right here, interest. Maybe you know what interest is in a financial sense, maybe you don't. Basically, interest is this really, really powerful, phenomenal thing where money can actually grow a certain percentage of however much money was initially present. Okay. So this can be money that you put in a bank account. That would be an example of good interest. This can also be money that you owe someone or some party, and the money that you owe can accrue interest and grow, which would be a bad case of interest. So this can be good or bad. This doesn't really have much to do with what we're talking about today, but you will deal with interest a ton throughout the rest of your life. So that is what interest is. So we might want to know, we're putting money into an account that pays interest. That means that the money that we deposit is growing a certain amount over time. So we might want to know, what's the interest rate? Meaning, what is the percentage that this money grows? How much does our money grow? Those would all be things that we need to know to answer these questions. Okay. We're going to answer a couple different questions in this video. I'm going to give you a couple examples of this type of a problem. Okay, we're going to use a couple different equations to do that. But before we do that, speaking of video games, somebody asked me to start putting some jokes in my videos. I guess they're probably a little bit too boring, so I'm going to throw in some jokes every now and then to try to spice them up. So here's your joke for this video today. Okay, what is the video game that you play while you're on the toilet? Just give you a second to think about it. What video game do you play on the toilet? Call of Duty. Yeah. Yeah, I know you're laughing. I know you're chuckling. I hope you are at least. So there's your joke for today. Call of Duty. I bet a lot of you are playing the real Call of Duty right now. But anyways, let's get back to our equation here. So first we're going to look at an exponential growth function. Okay. Exponential growth function looks like this, where A is positive and R is positive. Okay. Exponential growth function has a couple different pieces. I'm going to tell you what they are. Y in the exponential growth function represents our final amount. So we could be talking about money, we could be talking about population, we could be talking about a lot of different things. It's just our final amount of whatever we're talking about. A, this number right here, that represents our initial amount. So that's how much money or whatever we're talking about, how much we have at the very beginning. Okay? So in this example up here, our A amount would have been 10,000 because that's how much money we had at the beginning. Okay, R represents our rate of growth. So that would be our interest rate. Okay. The important thing about this is that we have to write this as a decimal in our equation. If we don't write it as a decimal, everything's going to be messed up. And T represents time. How much time? And those are always going to represent those things. That never changes. All right, so let's think about an example of this. We're going to use this equation. So pretend you work for a music production company, and your company creates an annual music festival. The inaugural attendance, inaugural just means first. Okay, so the very first time you did this, the attendance of the music festival was 150,000 people. And after that year, the attendance increases by 8% each year. All right? Tells us that our boss asks you to create an exponential growth function that represents the attendance after 2 years so that we can predict the size of the festival in the future. We know how much food to buy, we know how many chairs that we need or whatever. And we want to know how many people to plan for in future years. So we're going to try to build an equation to model. All right, so let's think about this for a second. The general exponential growth equation looks like this. I just copied that from up here. And all of these pieces represent something. We just talked about what they represent up here. Okay, so really what we have to do in this type of problem is go find everything that we can in the description of this situation here. We want to find each of these pieces in this description if we can. Okay, so let's think about it. Let's try to find A. Remember, A is our initial amount. So how much, we're talking about people, right? We're talking about people that are in attendance. So how many people were there initially? Or the first time we did it, how many people showed up? Well, it tells us that. The inaugural attendance is 150,000 people. Okay, so I just found A. All right, let's see if we can find R. Let's see if we can find R. Okay. R is the rate of growth. Well, it tells me that after the first year, the attendance increases by 8% each year. So 8%, that's going to be my growth rate. But remember, I have to write that as a decimal. Right now, it's a percentage, and I want that to be a decimal. So before I put that into my equation, I'm going to come over here and do a fast calculation. If you're not sure how to turn 8% into a decimal, all you need to do is 8, whatever the decimal is, divided by 100. Okay, you can do that on a calculator if you need to, or just do it in your head. That's going to get you 0.08. So that is our R. That's what we're going to look for here. Okay. All right, so I haven't done anything with time yet. And Y is what I'm trying to find, so I'm not really plugging anything for Y yet. That's going to be my prediction. So now we have everything that we need to go ahead and rewrite our equation. Okay, we're going to create a model here. So it's going to look like this. Y, the number of people that show up, equals the initial amount, which we saw was 150,000, times 1 plus r, which is 0.08, all raised to the t power. Okay, this is an exponent. T is an exponent. So I can simplify this piece a little bit more, right? I can add 1 plus 0.08, and it'll look like this. Rewrite the entire thing again with this part simplified a little bit. 1 plus 0.08 is 1.08 raised to the t. So this right here, that's going to be our equation. Right? That's going to be the equation to model our attendance at this festival. All right. So now that we've got our equation, let's think about what part B says. It's asking us how many people will attend the festival in the 5th year. Round your answer to the nearest 1,000. So then our boss comes to us and is like, hey, I want to know how many people are going to show up in the 5th year that we do this thing. So we know how many people to plan for. Okay, well, we can use our equation that we just created to help us figure that out. So I'm going to write out my equation again. I want to know how many people, that's why, that's what I'm trying to find. I want to know how many people are going to show up in year 5, okay? So think about it. I'm talking about number of years here. Where do you think I'm going to plug in this 5, okay? Talking about year 5. It's going to go in here for t. That's where I'm going to plug it in. So it's going to be y equals 150,000 1.08 raised to the 5th power. I plug in 5 for t because t represents time. And since I'm talking about 5 years, I'm going to plug 5 in for t. Okay, so now I'm going to do some calculator work here. You can use a calculator if you want. You can use a Desmo Scientific, or you can use your own calculator. Remember, I have to do exponents first. Can't forget about my orders of operations. I'm going to do exponents first, so 1.08 raised to the 5th. Let's do that real quick. 1.08 raised to the 5th power. It's about 1.47. I'm going to round a little bit. That's fine. So that gets me 150,000 times 1.47. And then if I multiply those numbers, multiply this number by 150,000, gets me about 220,399.2. But I'm talking about people, right? So I can't leave that as a decimal because I don't want to have 0.2 of a person show up to my festival. That would be kind of morbid. Instead, I'm just going to round it down. So I'm going to do 220,399. Okay. So it's going to be 220,399 people making my festival. Maybe another 5. Okay. So this is an example of an exponential growth problem. All right. You use this equation, exponential growth. You use this, big shocker, you use this when you're talking about something that's growing. So you're talking about growth. If we're talking about something that's increasing, it wouldn't make sense to use this equation because this is exponential growth.